Okay, this part of this differentiation, right, is dealing with the application known as rate of change. So it's split over two teaching worksheets. So if you take a look at differentiation 3A and 3B. So I'm going to do a basic introduction first. So this will cover the basic rate of change, the basic idea of increasing and decreasing function, and also there will be connected or related rate of change, which is in 3B. So all these are under one big application. So you can see as one application split into three sections. So this teaching worksheet will deal with two sections, one on the rate of change and the other one on increasing and decreasing function. Okay, so let me do an introduction first. So when we say rate of change, the word rate will be related to how fast. So when we say rates, we think about how fast we do certain thing, how fast we use up certain thing. So in a way, it's always related to time. So that is the basic thinking. So the basic notation that you will need to know will be, so for example, if you see the word rate of change of x, so if you look at this word rate of change of x, the differentiation notation will be dx dt. So t will be the timing. So it's related to time. So that's why it's dx dt. So when it is rate of change of y, then that will be dy dt. So later on, when in the next teaching worksheet, where you will be dealing with related or connected rate of change, you will have all the mensuration formula coming in. So you will be dealing with area, you'll be dealing with volume, so it get more complex. So for example, you can have like rate of change of area. So we usually use capital letter A for area. So that will be a dA dt. So when it comes to the rate of change of volume, we use capital letter for volume. Okay, then that will be a dB dt. So do take note that because it's related to time, the time is in the denominator. So if you somehow do the wrong notation, so for example, it's a dx dt, you accidentally write it as a dt dx. Sometimes it might cause some confusion or careless mistake along the way. Okay, so after the notation idea, it will be a basic concept that you might need to know. So this concept is necessary in higher order question. So there are some higher order question that needs this thinking, which is a fundamental thinking. So a very simple idea will be, if I take 3 seconds to transfer a 45 centimeter cube of water into a cup. So you imagine like a dispenser. So if you take 3 seconds to transfer 45 centimeter cube in a cup, so we can have an idea about the rate of change of volume, how fast the volume is changing. So in primary school thinking, we will be thinking something like, oh, it takes 3 seconds to transfer 45 centimeter cube. So this is the thinking idea. So you can think like primary school, 3 seconds take 45 centimeter, 3 seconds transfer 45 centimeter cube. 1 second, you will be able to transfer this amount, 15 centimeter cube. So we will translate this thinking to the standard phrasing, the rate of change of volume is 15 centimeter cube per second. So in the primary school thinking, that's our thinking, but we don't show it. So in a way, we translate it to how fast the volume is changing. So the volume is increasing 15 centimeter cube for every 1 second. So we assume constant. So it doesn't get faster or get slower. And in notation Y, that means, right, this is a dV dt. So there are some questions that involve this basic idea. So when we do rate of change, right, we are finding how fast a certain variable is changing. So when we talk about how fast, it's always related to time. So that's the notation and the general idea. Okay, and there are generic steps. So these are the main steps. If you look, I listed out the main 5 steps that you will need to use for the basic rate of change and for the connected rate of change. So I'm going to try to apply this into the example. Okay, so I'm going to try to apply this. So if you look at step 1, okay, you can reference it, you can turn back to your notes as I'm on page 2. So try to refer back to the steps. So for the first step, right, the step is trying to tell you, you must know what are the information given. So first step, you must know what is the information given. So I am given the formula for y, and I'm also given the rate of change of x. So that will be a dx dt. So these are the 2 pieces of information that I've gotten. Okay, then the second step, you got to know your aim. Second step, what are you supposed to find? You are supposed to find the rate of change of y when x is equal to 2. So find the, so you got to translate rate of change of y. So the notation will be dy dt when x is equal to 2. Okay, so you are given 2 pieces of information and you got 1 aim in this question. Third step, I think that will be the easiest because you just need to perform a dy dx. So you perform your dy dx based on the formula that is given to you. So in the connected rate of change, this will not be given to you. It will be the selected maturation formula. So here, do your dy dx. By now, you should be very familiar with your dy dx. Okay, so the 4th step may be the more challenging one. You got to form an equation to achieve your aim. So your aim is this. Okay, so there is a basic formula involving this. So dy dt, there is a fixed formula. So some students or some teacher actually introduce the formula like this. So this is the generic formula that you might want to follow. So this is a generic formula. Okay, so how does this formula come about, right? You can look at it this way. So you can diagonal these 2 things. So can you see I diagonal? dy and dt is vertical. So it is like top and bottom. So I kind of change it in this way. And I'm introducing in a dx. So essentially the dx is cancelled. So this formula actually comes about by introducing the dx. But in fact, it's actually being cancelled out. Okay. So you can diagonal the item. So the dy and dx, right? You make it diagonal. And you introduce something that can be cancelled. So that's how the formula comes about. If let's say you didn't want to think so much, you can just use this as a generic formula. Okay. You see how things go first, whether you want to do with the generic formula or you want to come up with you want to understand a little bit more on the formula. So once this is the formula, okay, what you should do is, right, the formula needed a dy dx. So the dy dx is a 6x. It needed a dx dt, which is already given to you right in the question. So that will be a 2. So eventually you got a formula. So I will suggest, right, you get a formula first. you get the formula first, and then you apply your step 5. Step 5, you got to sub in the relevant value information. So what information are we talking about? I need to sub the x equal to 2, because the question asks for dy dx when x equal to 2. So my approach is I get the formula for dy dx first, so I can earn a method mark for this. And then when x is equal to 2, my dy dt is equal to 12 times 2. So which is like 24 units per second. So we try to avoid substituting 2 here. We try to avoid substituting 2 in the dy dx. So there are some students, right, they will substitute 2 here. So we'll try to avoid that. We will try to sub the value only when I got the formula. So I got the formula for dy dt, then I sub the value inside. So that will be the generic process. Okay, so I will be showing you another question. So sometimes the question may not be so direct. So in example 2, I'm still going to be following the 5 steps, but the question is slightly indirect. So let's observe what about example 2 that is indirect. Okay, so step 1, let's write the information. I gotten the y, and I also gotten the rate of change of y. So that will be a dy dt. Okay, and what's your aim? Your aim is to find the rate of change of x when y is 10. So your job is to find the x dt when y is equal to 10. Third step, like what we mentioned just now, is just doing a dy dx. So the challenging one again is your 4th step. How do you get the x dt? So we can get a dx dt by doing this, by using the generic formula. So just now I show a generic formula. So dy dt is equal to dy dx times dx dt. So you can see it as a generic formula. Or you come up with your own formula. So I'm going to come out by diagonal the dx and dt. And then I introduce my dy. So essentially the dy is the one that's being cancelled away. Okay, so I will show you by both methods. You do whichever that you have done it in school. So the generic one, okay, you can write out the generic one. Okay, then you ask yourself, do I have dy dt? Yeah, dy dt is 3 units. So put in the 3 units. Do you have dy dx? Yes, you do have the dy dx. And then this is the one that you're supposed to find. So from here, you divide over, and you actually obtain a formula for dx dt. So we always want to obtain a formula first before we go to a step 5. Step 5 is just substituting the value. Okay, however, if let's say you are doing it by this method, then you got to understand what is a dx dy. Dx dy is essentially 1 over dy dx. So it will be like 1 over 3x squared times, so dy dt is 3. So all in all, it will still get the same formula. So if you do by the generic formula, you will get the same formula as well. So it doesn't matter, it should be the same formula. Okay, then the last part, I'm supposed to substitute y equal to 10. But I couldn't, because if you look at this formula, the formula needs x. It doesn't need y. So you need to sub x, but you are not given x. So in this case, you find the corresponding x. So you use this relationship. The equation is a relationship. So you use the relationship between x and y to find the value of x. And when you can get the value of x, you put it into dx dt. So it will be 1/4 units per second. Okay, so you can stick to the generic formula, or you can try to manipulate a little bit. It's your choice. I would say if you can manipulate if you can do this idea of manipulation, sometimes it do help in more difficult questions. Okay, so this will be the basic 5 steps, and stay closely to the basic 5 steps. If you stay very closely to the basic 5 steps, a lot of difficult questions can still be solved. Otherwise, you'll find that sometimes you really couldn't do because you don't even know what you're trying to do. Okay, so stay very closely to the 5 steps.